Hey, good morning, everyone. Unfortunately, I didn't prepare a joke, so I'll dive right into the presentation. This presentation is probably going to be a little bit of a palate cleanser. So we've been listening to enterprise decisioning using Causal AI, but the use case or the case study that I'm going to present here today is how we solve policy questions with Causal AI. I work for Dun & Bradstreet, and I work within the public sector team. And this case study was motivated from questions that we got from our clients within the public sector, federal and state and local agencies. And the analytics was completely done on the causaLens platform Decision OS. What is this study? When lawmakers, in our experience, what we see is when lawmakers implement a regulation, they are, of course, worried about the impact on the target group, but they are also worried about the impact on the ecosystem that the regulation hits. In our case, we are looking at, as you know, prescription drug pricing is a big topic, and many states have implemented regulations to reduce prescription drug pricing. And our client question was, how do prescription drug pricing, these regulations, we looked at not how they impact the target population, who are possibly the customers who are getting the benefit of the lower prices, but how does it affect the viability of the businesses that sell these drugs whose prices are being reduced by a regulation. So that was not the target group, but some indirect impact of what's happening in the macroeconomy as a whole, because that is definitely a consideration. So a little bit about the data. So Dun & Bradstreet, that's our business. We have a business database of millions of businesses worldwide, and we have rich firmographic, financial, payment, and other kinds of data in our data cloud, and that's where we pick the data from. And we used also a little bit of macroeconomic data as well to control for the prices and things like that. And method, we used a synthetic control method that we were helped by much help from the fabulous team from causaLens. So this was the setup of the problem. So next slide. So for this group, I'll just, I don't think a refresher of the synthetic control method is required, but since I have it on the slide, I'll do it in any case in 2 minutes. What the synthetic control method does, so as I said, as I was mentioning here, we have a firm level data set, but we required to do this in this analysis at the state level and compare what was happening between different states. So we had a bunch of states that were treated. For example, where the regulation was implemented, and a bunch of control states where the regulation was not implemented. And this is, when I say implemented versus not implemented, I mean a specific time period, which is for our study between 2016 and 2019. And we specifically selected this. This study was done recently, but we didn't want to go into the complications that COVID brought into the data. So it was our first sort of trial, so we just left out the COVID periods and just went with 2016 to 2019, nice stable period. So as I was saying, we had a bunch of control states, but a bunch of treatment states. So what we did on Decision OS is that the synthetic control method, it took a weighted combination of the control state and created a synthetic or a fake or a what should I say, fictional control group that we can then compare with the treated state. And the behavior of the synthetic control pre-intervention was very much similar to the treated group. But after the intervention, we have the observed impact, what is actually happening to the pharmacies, and then we have the counterfactual or the synthetic impact, what is happening to the pharmacies. And then when we have those two results, we take the difference of them, and that's the impact of the regulation that it's having on businesses. So that's very short way of explaining the synthetic control method. Now I go to the data specifications. I already said the population of interest was the pharmacies. And so we selected pharmacies from different states. And we had, I'm not going into the sampling right now. We had some selected characteristics of pharmacies that we selected from these treated states and control states. And what's the intervention? The intervention here, we saw that there were many regulations that have been implemented over the years, but during our period of study, the major ones were the four that you see on the screen here: affordability review, importation, volume purchase, and consumers cost sharing. So I'll explain a little bit of these later on. And as you can see, during this period of study, these were the states that had implemented it. And then model variables, I'll talk a little bit about the dependent variable or the outcome variable. It's called the viability rating. So Dun & Bradstreet has a collection of scores. So we rate businesses on various aspects of their performance. So for example, we would rate a business of, is this business going to severe delinquency in the next 12 months? Is this business going to fail in the next 12 months? Is this business going to do a payment default in the next 12 months? So this is a score also, which is called the viability rating. And as you can guess, this kind of gives us is the business going to file for bankruptcy or go out of business in the next 12 months. So that's the viability rating. And we use this to measure the viability of the pharmacy over time, as before the intervention and post-intervention. And then the treatment variable here, we needed something that links to regulation. And since we are looking at prescription drug prices, we needed some price data. So we created some price indices, so monthly state level prescription drug price indices using data primarily from open sources, Bureau of Economic Analysis or Bureau of Labor Statistics, which publishes this kind of data. And then again, I talked about the Dun & Bradstreet firmographic data. We have firmographics, we have risk scores, payment performance, financials. Those were our control variables that we used to build the synthetic control. So next slide. When we do something like this, a research or a case study like this, there's been a lot of literature where these kind of analysis has been done using difference and differences, right? So I had to have one slide here to say why we didn't go for that. So we actually tried to apply it, but we faced some caveats that in the end we went for decision OS and the synthetic control method. Here I thought I'll just, instead of showing you the difference results, which were not that great, I thought I'll show you the actual data. So this is the viability rating, the aggregated viability rating of all the selected pharmacies. So we averaged the viability rating, and this is the time series of that viability rating in New York State, and then two other states, New Jersey, that's where I come from, and also Connecticut, neighboring state, which could be control states, good control states. And and then this intervention was implemented in April 2017. So you see the the bar there. And then, of course, you see there's a little bit of delay, and I'll explain why that is. And then, you see there's an uptick in the yellow curve, New York, where the regulation was implemented. And then again, it comes back to the New Jersey level. So something about, here I have to say something about the viability rating. As I was saying, Dun & Bradstreet has multitudes of scores. We kind of rate businesses on any aspect, but we keep one consistent thing. We say that, how we maintain consistency is we say, no matter what we are measuring, the higher the score, higher the risk. So here, we are measuring viability, but we still have that principle applied here. Higher the score, higher the risk. So you read it, but since we are measuring viability, which is a good thing, opposite of risk, but it's the improving viability is when the curve goes down, that's when viability improves. So if you can choose one of the arrows to look at. So, but in this case, just to say it simply, I'll just say that if the curve goes up, that's bad for the pharmacies. If the curve goes down, that's good for the pharmacy. So that's how you can sort of set it in your mind, because it's a slightly unusual concept. So so parallel trends, that's must have sort of an assumption for difference in differences. And you see, if you look at the charts, it's, you see, there is a parallel trend, but it was not automatically. So we had to do a lot of sampling to come up with this. And, so what we saw mainly is when a regulation is implemented, the businesses on the border, and when they don't like the regulation, it takes them time to do it, but they would move to the other side of the border, especially the very, very small businesses. That's what we've seen in the data when we were, doing the research. And that kind of, destroys this parallel trend, because even if businesses are moving from here to there, it kind of, is not good for the sampling. So again, that didn't hold. And then the transient businesses kind of messed up our sampling, so we had to put them out of the sample altogether. And then, as I said, we had the state level analysis. So the relatively small sample, we didn't have the advantage of hundreds of pharmacies. And we wanted to do this analysis on a time series basis. So, difference in differences 101. How do we incorporate more and more effects? It's by dummy variables. So if we were evaluating all these 40-odd periods and introducing 40 dummy variables and their interaction terms, that is not a very good thing for our sample. We don't have the degrees of freedom to do it. So that will not really be, that will also give us biased results. And then again, I hate to bring up the data, Dun & Bradstreet data set again, but it's something we do. And I think this is where the beauty of our partnership with Decision OS kind of came to a head, because we have all these good attributes, and Decision OS was able to take these attributes seamlessly and sort of create a very, very beautiful counterfactual scenario for us that I'll show you on the next slide. Here is the results that we got on Decision OS of the counterfactual. So we abandoned difference in differences. You saw why. And okay, so here the top chart will be familiar. That's the New York, but it's not, now we don't have New Jersey or Connecticut. We have our beautiful counterfactual, who kind of very much mimics the pre-intervention and then the post-intervention. We can look at the impact very, very clearly. So this affordability review, a little bit about it is that they sort of construct boards and bodies of individuals that sort of try to cap the prescription drug spending. So they are constantly in talks with like med companies to sort of reduce the prices and things like that. So these boards do all the negotiation. So as you can see, Initially, there was a delay. Of course, the board was set up, and then they were setting up the ceilings and all those things. But then after the delay, there was a deterioration of viability where the curve went up. But then after the businesses weathered themselves into the system, the impact went down, and then they were together with the counterfactual, so not too much impact. It's between the confidence intervals, as you can see. The second one is a volume purchase. This was, you have New Mexico, and this was in 2019. So you can see we don't have much of a time series here, but you can still see the effect. Volume purchase is what states do. Is they use their kind of bargaining power to buy in volume, so the price is low, and this low price they pass on to the consumers. So this is a much more sort of a seamless, much more seamless, where maybe the pharmacies within the states are already participating. So as you can see, the impact is very, very short-lived. It's even becoming better than the counterfactual here. So that's the volume purchase, and then consumer cost sharing. So they implement this using coupons or deductibles, something that's already in the pharmacy's wheelhouse. So you can see there's very, very little effect of that. Pharmacies are not even impacted at all with this. So a little bit of uptick there, decrease in viability, but again, going back to the counterfactual scenario. The last one, importation, as you can see, it hits the pharmacies really hard. So this is implemented by buying low-cost drugs from prescription drugs from Canada and Mexico, and then flooding the markets with this. So this really impacts is pharmacies, and as you can see, their viability has really deteriorated, and I don't see this converging to the counterfactual at all. So our case study showed our client. This is, of course, not the client problem. We had to create a fake problem to show here. But the problem we solved for the client, they were able to see that the mode of implementation and the body of the population of interest where it's being implemented also made a big difference in terms of these kinds of regulations. So, I think this kind of helped them to build an evidence base for effectiveness of any kind of policy. And then I thought we were able to show them that this becomes very effective when they are trying to implement any kind of regulation. So we have clients within, so we have clients within public sector, all sorts of agencies. So we have a plan to apply this kind of methodology within regulatory shocks, just like this, natural shocks when the intervention is not a regulation but a natural disaster like a hurricane or wildfire that disrupts businesses, and shocks to international trade, of course, like a sanction that was put in, or the Baltimore Bridge broke. So something like that. And then the beauty of the partnership was that we were able to, there was a lot of research that went into it, but when we were kind of overcame our learning curve, with helped by the causaLens team, we were able to do this analysis in record time. I think we took less than a week and a half after we kind of became, we understood how the codes were working and everything like that. So that is record time for any kind of analysis that's done. So that brings me to the end of the presentation. Thank you very much for listening.
There were quite a few questions, but we are a bit tight for time, so I'm just going to ask you one, if that's okay.
Yeah, sure.
What are your robustness tests for synthetic control?
Oh, that's a great question. Sorry, I missed that part. Yeah, so so we did placebo test, and also one bias that can come into this analysis is through the functional form of the counterfactual equation that is being used to estimate the counterfactual. So Decision OS is already it has a lot of robustness checks built in, the placebo test, and it helps, and it also allows you to do the analysis using other functional forms of the counterfactual equation. So we were able to really verify that yes, this is the truth we are seeing, and it's not biased by any other, either the functional form or the data. So.